Yeah, and so how is that going to potentially harm people other than you if you sort of make the government charge a higher tax?
Like, depending on what kind of tax it is, some certain parties might be hurt more than the others.
Yeah, you're going to, like, we know that taxes create sort of a dead weight loss, right?
Yeah.
And so the harm that you cause to other people by saying that you care about this thing is the dead weight loss on everybody else of imposing the tax that you sort of are asking for by saying that something hurts you, right? Okay. So without me, society is going to make the choice that maximizes social welfare for everyone other than me. With me, they're going to make it for everyone, including me, right? And so my externalities is how much I shift the decision and thereby change the welfare of everyone other than me, right? So let's go through a numerical example of this. Okay, imagine we're back in our smoking example, but there's now a small room. So the value, there's one smoker, and the value to him is 100s minus s squared from smoking. And there are two other people, each of whom gets a harm s squared plus 5s from smoking. And now you're the third person. You get a value s squared plus 10s from, you get harmed an amount s squared plus 10s from smoking. Okay. So the question is, what would be the optimal amount of smoking from society's perspective if you weren't in the world, if you weren't getting any of these harms? Jackson, can you figure that out?
Okay, so you're going to want to set the marginal value of smoking to the marginal harm of smoking. So that's going to be 100 minus 2s equals 4s plus 10.
That looks 4s. Yes, exactly.
Okay.
So maybe someone out there.
Yeah, one that would be.
Yeah. Well, so you get that s star equals 15. Right? Okay. Now, what's going to be the optimum, including you, Jacob?
So we're going to have 100 minus 2s equals 6s plus 20.
Exactly.
Right, so that will be,
S squared equals 10, right? Okay, so you reduce the amount of smoking. Because you were there to be harmed by it, you caused the amount of smoking to go down. So the question is, what is the externality that by existing you create on everybody else? Israel.
So, I love that here. You multiply the optimal level of smoking with, you take without you and then with you.
Yeah.
So 90 times.
Remember how we do a Harburger triangle from before to calculate the dead weight loss?
Right.
Right? We can do that here too, right? It's the same principle.
So without you, we have the optimal level at 15.
Yeah.
With you, it's at 10.
Yeah. And you want to calculate the effect on everyone other than you, right?
So 90 times 15.
90 here is the marginal value at, where's 90 from?
Without you.
Okay, so the marginal value without you was 90 minus 6s, right?
Right.
And let me draw a picture of this. So if that's sort of like the demand, right? And this is the value without me. This is the cost without me. This is the cost with me.
So if you look at that difference in price at each of those equilibria,
Yeah?
so that's what you need to account for.
Yeah, so it's this triangle here. right? Because this is the value to everyone other than me that's lost as a result of moving from here to here.
Right.
Right? So the way that you get that, right, the height here is the marginal social value of smoking at the optimum without me,
Right.
which is plugging S star equals 10 into that equation there. So it's 90 minus 60, which is 30. Right?
Okay.
So this height here is 30, and then the reduction in quantity was 5. So that's this width here. So 30 times 5 is 150, and then divided by 2 because it's a triangle.
Okay.
Right? And so we get
75.
Yeah. Okay.
Wait.
Yeah?
Why isn't it, it seems like you have minus s squared, why would it be minus s, 3s squared? Because both the
Right here?
smoker and the other, yeah, and the other two people are all losing.
Okay. So I've got 90 times 15
That was 100s minus the 10s for the two smokers, I mean, the two non-smokers,
minus
5.
15 squared. Where's 15 squared coming from?
You're plugging in 15 to the s squareds, but you took minus s squared. I'm saying it should be minus 3s squared.
Yeah, it should be 90 times 15 minus 3 times 15
Okay.
squared, I think.
You have two positive and
no.
one negative.
No,
Yeah.
no, they're all gonna be negative.
Yeah, they're all negative. I mean, it's still 75 with
Yeah.
the same logic we did here, but I think
I think still-
somehow there's some things that are canceling
I
out,
was
and
just
we're still getting
confused.
75. But I don't know exactly why.
I was confused by the math of how that.
Yeah, but this is the right calculation over here.
Okay.
Yeah. Okay, so, but the thing that you should notice is you're still happy to pay that $75. Why are you still happy to pay that $75? Well, the gain that you personally get by reducing things by that amount is that before you were losing 15 squared plus 10 times 15, and now you're only losing 10 squared plus 10 times 10, which is 125, which exceeds 75. And we know that because the gain to you of changing this amount is equal to the integral of your harm, which is the difference between these two areas, between these two quantities, which is always going to be bigger than this triangle here, right? Because it also includes this triangle up there, so it's sort of twice that, right? Okay. So here's another example of the thing I drew up there. So the cost without you is this. The cost to you is this. The total cost to society is this. And this is the payment that you're going to have to make, the externality that you cause on other people. But the gain that you get, right, is the reduction in the cost to you. So it's the difference between this area and this area under here. This part is only the top of that, and the little box down here is what you gain. Okay, now, one thing to kind of notice about this is that note that as a function of how much you move the quantity, right, the amount you pay is basically quadratic because there's a triangle, right, Harburger triangle there. Now remember, I had you guys solve this problem where you had this little thing where you had to vote paying a quadratic cost to vote, right? Why would it make sense to have you vote and pay a quadratic cost to vote? Well, the reason is because how much you shift the outcome of election is proportional to how many votes you buy, right? And if you want to pay the externality that causes on other people, for the same reason as here, you should have to pay a quadratic function. It looks, yeah. Okay, so the most common use of the Vickrey-Clark-Gross mechanism in practice is what's called the second price auction. And in fact, Paul Milgram, who's a very eminent economist, yesterday talked about the use of something very similar to this to sell spectrum. Right now, the government is trying to put back together parts of the spectrum so that they can be used for different purposes to build, to put in like high-speed internet and LTE technologies. Okay, so what is the second price auction, George? Anyone else want to describe it? Oh, lots of people. How about Ryan?
So it's basically a sealed bid auction where the person who bids the highest wins, but you only need to get a price for the second highest bid.
Yeah, that's right. So everyone bids for an object. The winner pays the bid of the second highest person. And the reason he pays that, according to the VCG logic, is that that's the externality that he causes. Why is that the externality that he causes? Because if he didn't bid, the second highest guy would have gotten it. And how much does that second highest guy value it at? Well, whatever he bid, right? And so that's the loss to society of him having bid, right? Now, the key thing to note here is that I said that you always want to tell the truth, right? How do we know that here? Well, you always want to bid your valuation, which is VI, right? And the reason is that if I'm already winning the auction, then changing how much I bid doesn't affect anything, right? Because I always pay what the second highest person bids. So in a normal sealed bid auction, right, if I know I'm winning, then I'm going to want to reduce my bid as much as possible, so I just beat the next guy, right? But here I have no incentive to do that. And I never want to switch whether I win away from what would happen if I bid my true value. Why is that? Imagine that I bid below my true value, right? And there's someone else who bids between what I bid and what my true value is. Well, that means by bidding my true value, I could have won for less than what it's worth to me. And so I wish I'd done that. On the other hand, if I bid above what I really wanted to bid, the only time that changes the outcome is when someone bids in between what I bid and my true valuation. But if I end up winning in that case, I pay more than what it's worth to me. Okay. Yeah, go ahead.
What if two people value it the same? Wouldn't that create like a meta situation which like one person tries to pay like slightly more than what he values?
No, because if I bid slightly more, then there's always a chance that someone comes in between my value and that, and then I don't want to have won. And I'm actually indifferent as to whether I win or not if two people bid the same thing, because then I'm paying exactly what it's worth to me, so I don't care whether I win or not. Right? Okay. Yeah, go ahead.
Just wondering, but if we're paying the second highest bid,
yeah.
Why exactly does the bid, why exactly should the highest bidder bid higher than his natural value, since however high he bid, he will only pay a certain amount?
Because he might then end up winning at a price that's higher than what his value is, and then he's sad that he won.
Yes, but isn't his price fixed at whatever the second person bid?
Yeah, but if he doesn't know what the second highest person is going to bid, and if the second highest person bids higher than his value but lower than what he bid, then he's worse off, right? Because then he ends up winning at a price that's above what he's willing to pay. Now, in multi-unit auctions, in what are called package auctions, when there's not just like one object that we're selling, or not even a bunch of similar objects we're selling, but there's like a whole bunch of different stuff and we're trying to sell it all, you can use the VCG mechanism